to talk about on page 11, number 3, part A. So the directions for 3 ask you to solve the linear equation using either method. And that was like there was a handful of problems at the back, last couple of problems of the homework that you were asked to choose a method to use. For this one, you definitely could use either one. Substitution would work because the y doesn't have a coefficient in front of it, so substitution definitely would work. You can also use elimination just by multiplying the top one by 2. So it's kind of personal preference. I feel like a lot of people always kind of use elimination. Maybe it's a little less work, but that's what most people like just divert to. Let's just use elimination. But it really works for either way in this problem because of the y being by itself. So Sam, which way would you choose to solve this problem?
I would definitely go with substitution.
Substitution? So if we use substitution, Sam.
Alright, so you're going to subtract 2x from both sides on the top equation.
Yep.
And then you have like negative y equals negative 2x plus 4. And then you want to divide everything by negative, just negative 1. And then y is going to equal 2x minus 4.
Awesome. Good job. So take the x to the other side. Know that you have to flip all the signs because of the y being negative. Okay. Question. Okay, so what would you do then next, Caitlin?
Plug in 2x minus 4.
So you're going to take whatever you solved for y, that expression that y is equal to, plug it into the next problem. Don't plug it in back to the one you just solved.
Would it not work?
It doesn't work, no. You're going to end up with like 0 equals 0. So don't plug it back into what you just solved. It doesn't work. You got to plug it into the other equation. So instead of y, which I wrote y, you're going to plug in that 2x minus 4, and then that's equal to 8. So substitution, take a letter out, replace it with an expression. And then distributing this, we have 4x minus 4x plus 8 equals 8.
So 80.
So the 4 x's cancel, and you end up with 8 equals 8. Did anybody use elimination for this one because you just wanted to? If you used elimination, David, what did you get?
0.
Yeah, so if you use elimination, just to show you how the elimination would work, I would have a negative 4x, a positive 2y, and an 8, negative 8, and then on the underneath 4x minus 2y equals 8. So if you used elimination, you end up with 0 equals 0. If you use substitution, you end up with 8 equals 8. So you can kind of see both ways. What does that mean? Kate, do you know?
I had a question
Oh,
on
yeah.
elimination. So elimination is just trying to like make them both equal but like opposite signs?
Exactly, yes.
Okay.
So you want the same number in front but opposite signs. Sarah, what do you think about the solution? It means that there are many solutions. This is a true statement. 8 does equal 8. 0 does equal 0, depending which way you solved it. So it's a true statement. That means there are infinitely many solutions. Because what kind of line would these be if we graphed it? The same line. So if we got these in y equals form, it would be the exact same line. So you can still have like one line graphed on the other. Even though we're solving for it algebraically, your answer is going to be displayed differently. But if I was graphing them, it would still be the same equation.
If it like ends out like that, except the thing is like not true, would that be no solution then?
Yes.
Okay.
So if you end up with 0 equal to any number but 0, that's when it's no solution.
Okay.
And that would have been for number 23. Yes. So number 23, you should have ended up with 0 equals something else. Maybe, I think it was maybe a 0 equals 8.
Yeah, I think so.
I feel like an 8's in my head.
I was like, something that they don't understand.
No solution?
I thought it was really bad.
Yeah, me too. I was like, man, I messed
Yeah.
something up. Yeah, I just put don't understand.
So number
I literally just
23,
wrote no solution.
when you end up with that 0 equal to another number, it doesn't mean that you did something wrong. It just means graphically, if we look at them, they're parallel lines. So you still have those cases when you're solving it algebraically, but your answers are going to look a little different. So 8 equals 8, 0 equals 0. If you have numbers equal to each other, it's infinitely many solutions. Whereas if you have a number equal to a different value, like a 0 equal to something else, because your x is canceled, or your y is canceled, then it's no solution. Because that statement isn't true. If 0 equals 5, 0 doesn't equal 5. Or if 0 equals 8, it doesn't equal 8. That's not true. Questions for that? So 23 should have been no solution, and 31 should have been infinitely many. So there was one type of each problem that you ran into that didn't have a solution or that had many. All the others just had one solution. So we are now going to look at 47 and 49, those two problems. Those were two really good challenge problems, getting you to think from chapter 1, how we can eliminate fractions from the problem, and then how you apply like the elimination or the substitution to the problem. I like those kind of problems because that makes you think a little more, and to me, like, you should be thinking a little more if you are taking an honors class, because you should be going above and beyond. So those are really good problems. Nice test questions, right? So Jenna, we'll start with you and we'll see how Jenna solved number 47. Pull her up here. I'm going to pass around a stapler if anybody needs it. If you don't, just keep passing.
Okay, so these are the two starting equations, and they both had fractions, so we wanted to get rid of the fractions by multiplying by the least common denominator, and that would be 6 between 2, 3, and 6. And then for the bottom one, the least common denominator was 12. So after multiplying each of the fractions by 6, this would be the new equation, and then after multiplying these fractions by 12, this would be new equation. And then whenever you're using elimination, you have to multiply by, to get x the same, you have to multiply 3 by 5, and so you have to multiply the whole equation by 5, and then 5 by 3. So you get 15x plus 20y equals 25, and then 15x plus 21y equals 27. And you would get negative y equals negative 2, and then y would equal 2.
So Jenna chose to keep the coefficients the same but subtract the second equation there. So she subtracted that entire second equation instead of multiplying by a negative 3. Means the same exact thing.
And then to find x, you just plug 2 into the original equation, and you would get x equals negative 1.
Are there questions on that? Jenna, you can leave that up just for another minute or so, just to let everybody look at it. So when you're dealing with fractions in chapter 1, we solved equations involving fractions. The way you get rid of fractions is to multiply the whole equation by the least common multiple so that you don't have them in the problem anymore. We will use that process a lot throughout the year, so it's not going to go away. Fractions will not go away. Just because we're done with a chapter that involves fractions doesn't mean they're going to disappear. So they will continue to be in every chapter that we work with. And to get rid of them really easily, just multiply by the least common denominator or the least common multiple. They mean the same thing. So she chose a 6 for the first one because 2, 3, and 6, that's the smallest one, they're divisible by a 6. And then a 12 for the second one. 2 of them have 12 and then the 4. So her new equations are over here. Once you get those new equations, then choose whether you want to use elimination or substitution. Jenna, why wouldn't substitution work for this?
None of the variables.
Yeah, so I mean, it would work, but you're putting fractions back into the problem when you just got rid of fractions. So by using the elimination, you don't have to worry about solving for y, having a fraction in the problem. It does work, but it just, again, if you put fractions back in, it gets a little messier. Any questions? How many of you solved this correctly last night? Handful of you. Hopefully now that you've seen one, you'll kind of like remind yourself, put a little star next to it, but that's kind of the easiest process to use the fractions. So we're going to see another one as well. So you get at least to see both of them and how they were solved. All right, Bob, let's see what you have.
Wait, because for 55.
We'll zoom yours in a little bit. So that little black thing, pull it towards you. There you go.
Okay. So I did 49, and these two are the equations. So I started out by simplifying the first, and I got 1/2 x minus 1/2 plus 1/3 y plus 2/3 equals 4. And then I multiplied all of them by 6 to make them whole numbers. And then I simplify all of them to get 3x plus 2y equals 23. And then I move to the next equation, and I use substitution because the x, I got the x all by itself. And I plugged it in, and I simplified to get 6y plus 15 plus 2y equals 23. And I subtracted 15 and added 6y and 2y to get ay equals a. I divide by a to get y equals 1. And I plugged it in the equation to get x equals 7. And the solution is 7, 1.
So if you just want to leave that up there just for a minute too. Anybody have questions? So again, just to kind of look at this. I'll give you a little sticky pad back. So she first separated the x so that you have its own separate fraction. So when you have two numbers divided by, or two values divided by one number, you separate it by taking x over 2, which is really the same thing as 1/2 x, and then the -1 over 2 is really just 1/2. So that entire fraction splits up into its own two separate pieces. Same thing with the y. So y over 3 is really 1/3 y, and then you have plus 2/3. Common denominator is a 6, so she distributed the 6 through everything so that you no longer have those fractions in the problem. And you're left with the integers that combine your like terms, and then here's that equation. And you can see that substitution, so I'm glad you used substitution, because then you got to see like both. So substitution works for this one because it was x equals. So x was equal to 2x plus 5, and then you can plug that in. Nice job. Are there questions on either of those problems? So now that you've seen two, if you see another one sometime, hopefully you kind of remember, oh yeah, that's right, we could try and get rid of those fractions through the problem. Nice job. All right, so are there any other questions from last night's homework that you wanted to talk about, go over? True. 55. So number 55, in 1 week, a music store sold 9 guitars for $3,611. Electric guitars sold for $475 each. The acoustic guitars sold for $339 each. How many of each type of guitar were sold? So you can see the answer is 5 acoustics and 3 electric guitars. But again, we need to talk about how to get to that point. So if we want to come up with writing an equation, you have to think about the total number of guitars and the types that were sold. So that's going to create one equation for you. So Maddie Z, can you give us one equation that you use?
Sure. I said x plus y equals 9.
Yeah. I'm going to get both on here. I don't think it's going to work. So she said x plus y is equal to 9. And the x would be, what was it, the electric, y is the acoustic. Yeah. And then your second equation, David, you have the other one?
479x plus
equals, say it again?
3,600.
Good. 3,611. So that first equation, the x plus y equals 9, that involves the total number that they sold and the two types that they're selling. So we're selling electric guitars and acoustic guitars. Pretty much, I think, in the 3 problems that we did, like the 2 yesterday in the book and then this one here, that first equation was in all 3 of them. So the total is equal to the 2 objects that we're working with through the problem. And then the second one is talking about how much they cost, and then the amount that they made from that cost. So in this case, you could set y equal to negative x plus 9, and you can use the substitution method. If you chose to use elimination, you'd multiply the top one maybe by 479 or by 339, depending if you want to get rid of x or y. The numbers get really big if you start to multiply by large numbers. So I think substitution probably is the easiest way to solve number 55. But again, it should have been a 5 for the acoustic and a 4 for the electric guitars. Questions with that? Are there other questions? So I think everybody got the stapler that needed it. If you could place your name on the top of that, please, and pass it forward with a smiley, a frowny, or a neutral face.
And we don't have to, there's not a problem that we have to do it.
No.
Would you like to do one?
Actually, I love it.
I'll add.
Yeah, I want to do one. So I can be done. You don't have to do 2 a semester, right? I mean, I know, you're from another school. There's other people in I'll do it tomorrow. In school? See, what breaks in here is.
Stapled together.
I know.
just assume they're all right.
I didn't put her last name. Well, I doubt that. I bet you'll find out.
You think so? Maybe. All right, ladies and gentlemen, if you can look at this worksheet, please. So the first page is the graphing page. You're doing the evens of this first page. Just the evens, don't do more. The first 3 questions, they're matching. You're only doing number 2. So you have your choice of A, B, or C, but you're only matching number 2 with A, B, or C. And then for the next group, it says solve the linear system and estimate the solution, and then check it algebraically. To check it algebraically, you can just take that number and plug it back into the original equation and see if it works. On the back of this, the word problem number 16, if you want to use algebra to solve that instead of a graph, that's fine. So if you want to graph it, you can graph it in your calculator, but if you're graphing in the calculator, show me the graph that you have, what the calculator is showing you. Or you can use algebra to graph 16. So you're doing evens for the first one,
For 3.1.
for 3.1. And then to give the odds a little bit of love too, we're going to do the odds on 3.2. That's all algebra. 3.2 you must put on a separate piece of paper.
That's 3.2? 3.2 goes on a separate piece of paper?
3.2 must be on a separate piece of paper.
Darn it.
The answers are on the back. So all of the answers to the even for the first and the odd to the second are all in the back. Please be checking your answers to see that you are getting them correct. And you have 20 minutes, which
Ooh, we
is a
should-
ton of time.
we should
I
finish.
was truly thinking about just skipping this
Bless you.
and not reviewing and just moving on. But
I get
Do you think we
Your
should just
time.
awesome?
I'm hoping that, you should be able to get the first page done if you're working.
I'll get it over.
So I'd like you to stay where you're sitting because I wanna pass back your tests, your notebook quizzes. So please just stay put, work with the people around you. If you have questions, let me know, especially once you get that test back. Let me know, we'll go over the test, what questions that you have on that test. Yes.
Wait, we only have to do number 2, right? Number 10. Take one.
I never take that.
Zoom.
In this class?
Okay, go to button.
I heard about it.
Yeah, it's not like I'm really stupid. Hold up.
Okay, I'll just write it. What? Wait, 2/3?
Oh wait, no, that's not that thing. Wait,
She does this like every year, every time.
It's because I never.
I never understand.
Am I?
Yeah, this is it. You always oh my goodness.
No, you just like every year you argue. Wait,
Yeah, I do.
what do you mean?
Dude, I hate negative numbers and fractions. I'm fine with this.
Oh no.
Oh no.
I didn't know about 11.
Get out of my god. Is that your science?
Me and Page's tests are out of different sorts. Hers is at a 52, mine's at a 55. Okay.
Make sure, let me make sure I add that.
Okay.
No, no.
Oh, okay.
So just make sure that I like have it.
Can I check now?
Yeah, yeah, yeah.
Who made this?
Oh, yeah.
I just love math so much.
Oh, that's so upsetting.
Honestly,
I'm just over 50% English. Yeah.
you know, with my legs,
Oh, yeah. Oh, yeah, you put it out of 52.
it would technically.
Well, I mean.
Even on the recent one, we were punching them backwards 3 times.
I've done like one project. I'm
Who was right?
behind. I'm the last person.
You're not
Always
far away
seems
from
that
it.
way.
I got it.
Oh, you're fine.
Yeah. One of them.
I just, some of my notes went always.
It's not there.
Yeah, it was out of 52 in power. Never bought this though.
That's
Is it right? Oh my god.
What?
Oh, this is like what am I heard?
I know.
I don't want to hear it.
Yes.
I was just confused. I've always heard this right of like increasing half the name. I said, I don't know what the sign
And it
is.
says fine slope. That's the first question.
That means it's not right there.
That's not the slope. That means it's undefined. The slope is undefined
Okay.
and it's a vertical.
Alright, I guess. So that's all I was. Everything else
That's it.
makes sense.
I mean, they're taking off the whole one. Yeah. There.
Yes.
I think those are like.
Thank you. Would you say that the policy would do stuff for practice like credit or?
Oh, you can turn it over up until the end of the chapter.
I made up 400.
Friday's my breakfast turns off, especially like.
Number 8 to 8.
I'm gonna do great.
Actually, I'm gonna do It's a yeah, see.
I like just have to do it.
The notebook.
You know,
So nice.
Really? No, my dad will.
Oh, you made it.
Cool. That's
I was like, wait, what?
your dad.
Oh, wait, wait, didn't look like actual notes.
Oh, yeah.
I didn't read it.
Yeah, I passed them.
If it was right,
That's
When you lose track of what the testing was homework.
yeah, really though.
you would not. But for my positive
Sorry, pause environment, you're right.
That's not a positive.
Does anyone have questions on the test? How about questions on the notebook quiz?
Yeah, me too.
So-
That's the one thing I would.
The next notebook quiz will be at the end of chapter 4. So keep the homework in a safe place. So it'll be at the end of chapter 4, which will be probably like the first or second week of November. Probably the first week of November.
Wait, what homework?
Like the next notebook quiz.
Yep. I didn't get homework. I know.
Yeah.
That's actually really good writing, like why Well, yeah, 'cause 9 or like half of 9 weeks.
Oh,
And
it definitely was. So I should have put it in here.
Yeah.
It's the, remember it, it's 2.7, it wasn't. It's right here. Dude, I'm not talking to you, I'm talking to someone else. Look. Look, 2.7, practice. Right. Well, 18, right?